Hey everyone, welcome to another repair video. Today we're going to be taking a look at this Nintendo Switch, and this is another liquid damage Nintendo Switch, which is a fairly common repair which I'll get in this workshop. So the Nintendo Switch is pretty renowned for liquid damage, and usually it's a relatively simple fix. Sometimes it can be rather difficult, but most of the time it's generally easy to fix. So what I want to do before I actually get started with taking it apart, I want to see if I can figure out roughly what's going on with the console based on what kind of current is being drawn from the charger. So I've got myself here a USB ammeter and a USB cable. So this is a 15 volt cable. It supports power delivery, so it's absolutely perfect for the Nintendo Switch. So I'm going to plug that in there. Before I actually plug it in, I'm going to confirm it works by plugging it into my own phone, just to make sure that everything's working as it should. For some reason, that's not working. Oh, there we go. Never mind. Ignore me. Okay, so, yep, that's working. It's bumping up the voltage, as I expect. Fast charging on there. So, that is all working. So what we should be getting on this switch is we should be getting 15 volts. And basically, it should start at 5 volts and then bump up to 15. Sometimes you don't even see it, it's that quick. But that would be the USB power delivery at work. So let's see what this does. Yep, 5 volts and 15 volts. We're getting 0.13 amps. No display on the screen. So, judging by the fact that the power delivery system is working, so basically what happens when you plug in a USB power delivery charger or a USB power delivery capable charger, what tends to happen is the charger will get plugged in, it will supply 5 volts initially, but then the console will say, no, hang on a minute, I need 15 volts, or I need 12 volts, I need 9 volts, I need 20 volts, whatever it is. And then the charger itself will supply the 15 volts or whatever to the device, and it can charge normally. So this is actually working when it comes to the USB power delivery side of things, because it is bumping up from 5 volts to 15 volts. So I'm not sure if that actually comes across. It does take a second to bump from 5 to 15. So 5 volts and 15 volts within a second. So yep, power delivery is working, but we get a solid 130 milliamp current draw. Now the issue with that appears to be charging, albeit very slowly. That appears to be charging, but the issue with that is the fact that we've got a solid 130 milliamps. Now, a device of any kind is never going to give a firm, or never going to need a firm amount of current. It fluctuates. It moves up, it moves down. So I would expect it, if it was charging really slowly, for example, if the battery was completely dead, I would expect this to bump up between, 0.11, 0.12, 0.13, and keep going up and down, up and down, up and down. But this isn't. It's a firm 130 amps, 130 milliamps. So that tells me that there's some kind of short, and that it's drawing 130 milliamps at 15 volts, which is going straight to ground. So there's definitely an issue with something there. Now, if we take what we've learned in the past, so if you've worked on these before, the one thing that you can do is something called pattern recognition. So pattern recognition is where we'll, for example, plug in the charger, we'll see a certain amount of current draw, and of course we'll generally know roughly what's going on with the device based on what kind of current is being drawn from the charger. In this case, with 130 milliamps at 15 volts, it's typically an issue with P13 USB. So P13 USB is the video IC, and I'll say typically because it can be related to something else. We'll have to see when we get inside the console. It can be related to something else. There's a missing screw there, so duly noted. I don't have any of those screws spare. But basically, usually it is a issue with P13 USB, and usually replacing just that one component will fix the issue. Now this is liquid damaged, so it could have a lot of other issues as well. And I get suspected spam trying to call me while I'm trying to film. Go away. And if you want to help stop getting spam calls, so if you don't want me to receive any more spam calls, what you need to do is you need to click on a big red button just down below this video. It is absolutely no risk to you. Just give me a chance. Subscribe. And then I might not get any more spam calls. So, yeah, I'm going to take this apart. Another screw missing there. I'll take this apart and we'll see if we can figure out what's going on with it, shall we? Okay, liquid damage indicator has been set off. And we have something here around the backlight connector. Okay, so we also have corrosion here as well. Actually, before we do anything else, let's test and see if it will turn on with a known good battery, so a charged battery. So what I have here is a bench power supply cable. So this circuit board here is the circuit board that's located just here on a battery, and then I've run that off to some banana jacks to my bench power supply. What I do, rather than having to keep a charged battery, I just supply this cable with 4.2 volts, and that replicates a 100% charged battery. So that can allow me to test these boards on the fly, just to see if it turns on when I plug in a full battery. So let's see what happens. So we get 0.000 amps current draw, and then we drop the cable. That's just normal. Start calling myself Linus. Okay, and we don't get any current when we try and turn it on. Has my bench power supply cable gone into sleep mode? So one of the problems with this is that when you disconnect it from the bench power supply, sometimes the boards go into sleep mode, depending on the board revision, I think. But sometimes they go into sleep mode. So I'm going to test the voltage on this and just see if we get a full battery. We don't. So there's absolutely nothing on there. So that is completely dead. So what I need to do is I need to get another console and activate it. So the way I do that, I've got a test board right here. And the only way to get around this is to keep supplying power at all times. So if you're like me and you have to keep changing leads on the bench power supply, then you can't do that. So what I'll do is I will just activate it by connecting it up to my test board here and just popping in the power supply cable. It turns up to 15 volts. And now I'm getting current draw from the bench power supply. So now, when I test the voltage, I'm dropping everything. I've got cables twisted all the way around. But when I test the voltage on this now, I should get 4.2 volts at the connector. Yep, 4.18 volts, which is absolutely fine. So, a bit hard to get a connection there. .18 volts, so with the voltage drop that is absolutely fine. It will still replicate a 100% charged battery. So I'm happy that I can use that as a test cable now, a test battery. And let's try and turn it on. And we get 180 milliamps current draw, and then it stops dead. So basically what happens when you try and turn this on, it will go through a boot sequence. And the boot sequence itself will perform necessary checks. So it will check for like the M92 chip being, fully functional, the P13 chip, the RAM, all of that sort of stuff. Basically, again, pattern recognition tells me there that this is probably something to do with P13, 180 milliamps is usually something to do with P13 USB. So what we can do is we can do some tests inside the chassis, but there's no point because either way this board is going to have to come out. There is definitely a component issue somewhere on the board. So no matter what, the board has got to come out, so I may as well just take it out before I do my tests. So I will say, while I'm taking this apart, that any of the tools, the equipment, the test equipment, all of that sort of stuff that you see in any of my videos, I do provide Amazon affiliate links in the description, in the video description, to all my videos. And if you use any of those links, or if you even just use that link and buy something else on Amazon, something I haven't got listed, then I'll get a little bit of a kickback. It does help out the channel a bunch. It does help me to continue doing these videos. I mean, I do them anyway, but it does help. Okay, so there's the board out. And it might be around the fuel gauge IC which is causing the problem. So let's have a look under the microscope and we'll do some tests. I did notice something just here. So I'm not sure what that mark is around there, but actually, yeah, that's corrosion. So there's corrosion around this IC here. This is the fuel gauge. This is what tells the console basically how much charge the battery has got. It's called a fuel gauge, and that is definitely damaged. So we've got some corrosion around there, so that might need replacing. Yeah, let's just do another visual inspection. So the max IC, this is responsible for taking power from the battery, I believe. No issues there by the look of it. So I'll continue to scan around. No signs of damaged components around the CPU, which is good, or usually. Let's take a look on this side. So we have a very wonky speaker connector for some reason. So we've got some damage around BQ24193. So like I say, this is the battery management IC. And M92T36 area looks good. This is a Chinese board, or Australian. I think they all still work, no matter what. Alright, everywhere else appears fine. So it is important to do a visual inspection first, just to give you a general idea before you start messing around of what components might be faulty. So it looks like it might just be around by the fuel gauge IC so far. But the one area I like to test on every switch is M92T36, and that is because I can test both M92T36 and P13, and also the CPU as well. So I can test for a short on the CPU on M92 as well. And I'll show you how to do all of that. Hopefully we can figure this out pretty quickly, because time is money. So right now I've got my multimeter into continuity mode. That's the mode that's going to beep when we complete the circuit. So that's going to tell us if we've got a complete circuit between ground and some of the components around here. So when I test these components, we don't want to see a completed circuit between ground and the component, or at least not on one side. So one side is going to be ground on the capacitors, but we don't want to see a completed circuit on the other side which goes into the actual chip itself, because that would mean we have a short. But actually we do want to see that, because that makes our life a little bit easier. This is the CPU cap just down here. So this capacitor just here is linked directly to the CPU, and that's not short. Excellent. That is great news. And this one of these caps here, I can't remember exactly which one, but one of these caps is linked to P13 USB, and those are not short. Let's test this MOSFET. Good. Fuse is good. filter is good. Yep. Okay, so the only issue I'm seeing so far is around the fuel gauge. Let's test this coil. That coil is good. I believe that gives around about 2 ohms resistance. Let's test for shorts around here. Let's just try and scrape some of this away just to actually make a contact. And no short. Alright, no shorts around here to be concerned about. So the only thing I'm seeing so far is around here. This is the only damage that I'm seeing so far. So I think the best option to do for this is to repeal and replace. So what that means is basically that I'm just going to remove these components and replace them. Because me see bad, me replace bad. And that's generally how it works. That does look a bit charred, to be honest. If you try and scrape away at that, it does look like it's got fairly hot. It does definitely need replacing. It's not going to take long to replace it. So I'm going to add some flux there just to help me to remove these components. And there's all of those removed. Just add some more flux there. And then what I'm going to do is I'm going to replace all of the solder that's on here with some fresh leaded solder, just to lower the melting temperature. I do want to wick these away, and those pads are incredibly small. I don't want to risk damaging them. And not only that, you should never solder on top of corrosion, because it will cause issues further down the line. This area here has got hot. So when I wick this away, that corner there is probably going to come away. So the conformal coating around there will probably come away from the board. But that's fine, as long as it doesn't damage the pads. So we're going to wick to clean these pads. There we go. Let's just clean up this area. So I'll just use the isopropyl alcohol there to clean that up. So what I want to do now is I want to put some fresh flux down and just basically replace the solder. Now that the pads are clean, I can replace the solder with some fresh solder, knowing that the corrosion isn't going to cause any further problems because it's been cleaned off. So the one area I don't want to replace the solder is going to be on that BGA chip, but everywhere else. Whoops, I left one there. Okay, so I'm going to get a donor board because I don't know the exact value of the components. So here's my donor board, and I can take the fuel gauge off this. I can't take these other components. As you can see, I've removed those components from there. It is a fairly common area to die. Okay, so I can pull different components off different boards, that's fine. I did just put that component in place off camera. Okay, and now I should be able to just add some flux and just flow these down into place. Okay, so now I'm just missing a BGA chip. Okay, so I've got myself a donor chip here. And I do just need to reball this real quick. Okay. That should be okay. It's a very small chip. It should be fine. Okay, that went out of focus there because the mat expanded, but it should be alright. So let's just see if that's going to work. And we are getting upwards of 600 milliamps current draw, so I'm going to let that cool down. I think this might be working. So I'm just going to give it a spray. So that was isopropyl alcohol I was using to spray it down. Okay, so I might as well just pop it back in the housing just to see if we get any kind of life. If I see any kind of life at all, I'll put it back together fully. But for now, I'm just going to basically put it back together enough to power it on. So I'm going to use my test battery or test battery cable. Let's pop in the backlight. So we only need the backlight and the LCD. I can prompt it to boot using the charger. So let's just see what goes on. And we get a charging symbol. That is signs of life. That is signs of life, my friend. So now I'm going to put it back together enough to give it a full test. I'm not going to worry too much about the battery for now. Although the battery is probably completely dead. But like I said, I'm going to use my bench supply cable because that saves me having to wait half an hour while I'm filming a video. That's the only problem with working with devices with a battery. Sometimes you have to sit there for half an hour just to wait for it to charge enough to turn it on. And that is a nightmare. So that's one of the reasons that I made the bench supply cable, because I can just test it on the flight and then worry about charging the battery up fully once I put it back together after the video has been done. Okay, that's all of the, well, most of the connectors reconnected. One thing I am going to do is I'm going to pop the little screw up in this top middle corner. Top middle corner? How is there a top middle corner? Well, it just is, trust me. There is a top middle corner. So this top middle corner screw goes in. Reason being, if this works, I don't have any reason to disconnect this module again, because as you can see, it is covered up. Or rather, it is covering up the screw for the top middle corner. Yes, there's a top middle corner, okay? There really is. Oh dear. Anyway, let's just secure a couple more things in that have a risk of being damaged during testing. So we've got the module and the USB-C port. Okay, and now let's use the bench power supply cable. Like I said, I'm not worried about actually charging the battery immediately. Let's try and turn it on. We get a Nintendo logo. We get the second boot. Okay, that did do a boot loop then. But that is working. Told you this was Chinese. That is booting. Yeah, I can't navigate in Chinese. I'm sorry. Well, I kind of can. Just from muscle memory. And it's picking up Wi-Fi. There we go. That's all working. Does it dock? Does it dock? That's the question. So let's get my dock breakout cable. So breakout cables are galore around here. Okay. This is getting a little bit warm. Let's put the heatsink back on before we go any further. Now that I know it's booting, I can put fresh thermal paster on. Okay, that should keep it cool. So now let's see if it's docking. So I've got myself a breakout cable here. This is a Thunderbolt cable which goes inside the dock on a male to female. So male at the dock end and female at the dock end and male at the switch end. And we get a green light on the dock. And we also get a display on the dock. That is absolutely fantastic. So it's docking. It's, well, appears to be charging. I will confirm that. Everything else appears to be working fine. Let's just test the Joy-Con this side. That connects. Let me find another one for the other side. And that one connects. So Joy-Cons are working. It's docking. It's charging, or it should be charging because it's docking. The only thing I don't have immediately to hand is a test game. So I don't think I've got a test game lying around which I can use. Not immediately, but I will do that off camera. That's not important. That's pretty much not related to the repair. But this console is fixed. Let's just unplug this and see what kind of current we're getting on a normal charger. So, or rather on the charger with the normal battery. I can't test that with the breakout cable because it replicates a full battery, so it doesn't actually send any power to the battery. Okay, so we're getting 120 milliamps. This is what I was talking about earlier with the current draw bouncing up and down. Well, no, it's not doing it. But we are at 15 volts, 140 milliamps. That will increase in a minute. So that will start to increase as the battery gets more power in it. But you see how the voltage is bouncing up and down? So it's not static, it is dynamic. And there you go, bouncing up and down as it requests more power. So between 140 and 150, and then will bounce up and down, and then it will stick on 150 in a few seconds, and then it will move from 150 to 160, and it'll keep going up until it gets to a normal 0.46 amps or 0.53 amps for slow charging. When it's ready to start fast charging, it will bump up to around about 1 amp, and basically that's how it works. But yeah, this console is complete. This console has now been saved from the scrap heap, of course. And it turns out that the only issues with this, my initial thought was wrong. So I originally thought it would be a P13 USB issue, but it wasn't. It was related to the battery management circuit. So basically the fuel gauge IC, which is responsible for telling the console how much power the battery has got. So by replacing all of those components around there, the reason I replaced all of them wasn't because they tested bad, it was because they looked bad. And sometimes that's all you need. So by replacing all of those components, including the 17050 fuel gauge IC itself, this console works. And this customer should be nice and happy. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to answer. If you want to organise your own repair, you can do so by getting in touch using the links in the video description. There's an email address there where you can get in touch, and I'll do my best to help you out. If you are new to the channel and you like what I do, then please be sure to hit the subscribe button and turn on the bell notifications so that you don't miss any future uploads. Finally, if you do want to support the channel, you can do so by either clicking on one of the Amazon links down below. That all supports the channel. I'll get a little kickback for that. You can become a channel member by clicking on the join button below the video. And you can also become a Patreon supporter using the Patreon link in the video description. All channel members and Patreon supporters do get early access to videos, so that is one perk amongst others that you get for supporting the channel. But that's going to be for this video. Thank you very much for watching, and until next time, I'll see you later. Bye for now.